We are going to use Tinkercad to simulate problem number 1 using Arduino Uno R3. To do that, click the Create button, then select Circuits. After that, you will be redirected to the environment, or you can use components such as Arduino Uno R3. You can simply drag and drop the components and rename them. Then, click the Code button and select Text to be able to edit and paste the sketch. As you can see below, it is the serial monitor where you can see the output and also send, clear, and toggle the graph. Now, I am going to paste the sketch of version 1, using a switch statement. After we click Start Simulation, we can now test the logic to see if it is really working. Based on the given problem, if the digit is between 1 and 3, the program multiplies it by 10. If it is between 4 and 6, it multiplies it by 100. If it is between 7 and 9, it multiplies it by 1000. If it is 0 or if the value is not a digit, the program must report an error. The switch statement evaluates the value of digit and executes the corresponding case. If the value of digit matches any of the specified cases, the corresponding block of code is executed. If none of the cases match, the default case is executed. After executing the corresponding block of code, the break statement ensures that the execution exits the switch block. We can then clear the serial monitor to test version 2 of the code using nested if-else statements. Start the simulation and, based on the given problem, if the digit is between 1 and 3, the program multiplies it by 10. If it is between 4 and 6, it multiplies it by 100. If it is between 7 and 9, it multiplies it by 1000. If it is 0 or if the value is not a digit, the program must report an error. In this version, nested if-else statements are used to achieve the same result. The input digit is checked against different ranges of values using if-else conditions, and based on the range in which the digit falls, the corresponding score is assigned.
In problem number 2, I'm going to write a code that prompts the user to enter the names of 2 primary colors, which are red, blue, and yellow to mix. For example, when you mix red and blue, you get purple. When you mix red and yellow, you get orange, and when you mix blue and yellow, you get green. If the user enters anything other than red, blue, and yellow, the program should display an error message. Here is the code I created to make this problem happen. This Arduino code sets up a serial communication and continuously prompts the user to enter 2 primary colors, red, blue, yellow, separated by a space. It ensures the prompt is displayed only once by tracking a Boolean variable, prompt displayed. Upon receiving input from the serial monitor, it reads the input string and trims any leading or trailing whitespace. It then checks if the input contains a space character to separate the 2 colors. If the input is properly formatted, it extracts the 2 colors and converts them to lowercase for case-insensitive comparison. It verifies if both colors are valid primary colors, red, blue, yellow. If valid, it prints a confirmation message with the entered colors and determines the result of mixing the colors, example, purple, orange, or green, based on predefined combinations. If the input is invalid, example, not containing a space or containing invalid colors, it notifies the user and prompts for valid input. The code employs a delay of 100 milliseconds to prevent excessive loop execution and manage serial communication. In conclusion, this program showcases a well-written and precise solution for mixing primary colors on an Arduino platform. With its clear logic and effective implementation, it ensures seamless user interaction and accurate color blending outcomes. By adhering to best coding practices, this code exemplifies the principles of Arduino programming at its finest. Thank you for exploring this program with us.
Before we simulate problem 3, let's set up our environment in Tinkercad. To do this, just click Create, then Circuits. Find Arduino Uno R3 in the Components section and drag it in the working space. We can rename it whatever we like. Let's name it Area Calculator. Then click the Code button and select Text. As you can see, we have a default code for the Arduino. Let's replace it with the code for problem 3. Open the serial monitor and start the simulation. Based on the given problem, at first the program should display the menu for the user. If the user enters a number outside the range of 1 to 4, it will display an error message. If the user enters option 1, it should ask for the radius of the circle. It should not accept negative values for the circle's radius. After the user input a positive number, then it will display its area. In addition, the program will display a message if the user types Y, then the program redisplays the menu and asks the user to enter their choice. Otherwise, the program should now exit. If the user enters option 2, the program should ask for the length and width of the rectangle, and then display the rectangle's area. It should also not accept negative values and display a message if the users want to continue. If the user enters option 3, the program should ask for the length of the triangle's base and its height, and then display its area. Same with circle and rectangle, it should not accept negative values for computation, and also displays a message if the user wants to continue. Then lastly, if the user enters option 4, the program should end.
For this part, I will explain how the program works, and below will be the demonstration of the program. This part of the code sets up a loop that will continue until valid input becomes true. This loop is used to repeatedly prompt the user for input until they enter a valid numeric value. Here, the code checks if the next character in the serial buffer is a negative sign. If it is, it removes it from the buffer using serial read. This prevents the negative sign from interfering with passing the numeric input. Similarly, this code checks if the next character in the buffer is a decimal point. If it is, it removes it from the buffer. This allows for floating point numbers to be entered without causing errors. This part checks if the next character in the buffer is either a new line or a carriage return. If it is, it removes these characters from the buffer. This prevents them from being included in the numeric input. This part of the code checks if the next character in the buffer is either a space or a digit. If it is, it passes the input as a float using serial.parseFloat, assigns the value to the grades array, updates the sum and lowest variables, and sets valid input to true to exit the loop. If the next character in the buffer is not a space or a digit, it clears the input buffer using serial.read to discard any invalid characters, displays an error message, and continues the loop to prompt the user again for input.